Okay, it's time to get started. So welcome to this session. Great to see so many people here. So talking about search and SharePoint. My name is Jan Inge Bergseth. I'm working out of Oslo in the Search Center of Excellence. Been following this product for 13 years now, so related to architecture. The architecture back then was really simple, just a few boxes, one with binaries and one with scripts and configurations. So it has really evolved. It's a lot more into the product now. It's much more mature. I know it's late. Hopefully the great content will keep you awake. Some coach once told me that on a scale from 1 to 10, 10 being really loud and clear, my voice was about 0.5. So, but I hope the content will keep you awake. Okay, so what we'll talk about today is the search architecture. We'll go into details related to each of the components and talk about the features, new features, and how you can use it. Then we'll talk about scaling, some important aspects related to scaling. And then finally, we'll talk about some migration paths. Okay, let's start with the architecture. So, those of you who know search and the architecture from before, from the latest versions of FastServe for SharePoint 2010 and the latest versions of the ESP Fast product, probably recognize most of these boxes. The boxes are pretty much the same, but the content within has changed a lot lately. So there's a lot of new functionality and features in the product. All the orange boxes are within the search service application and is a unit of scale. The different components we have can be grouped into the feeding chain, the index core, query chain, and the analytics service. Let's start by talking about the feeding chain. So this is probably the component that has changed the least, the crawler. As you can see, we have all the out-of-the-box connectors as we used to have from FastServe for SharePoint. We lost a couple of the more fast-specific connectors, but the other ones are still here. We have the web crawl, file shares, SharePoint. And related to SharePoint, though, there's a new feature called continuous crawl. Continuous crawl is a great feature to keep fresh content within your index. It's still kind of an incremental crawl kicking off at a given time interval, but different from the incremental crawl is that it doesn't wait until the incremental crawl is finished before it kicks off a new one. That way, making sure that the freshest content is always indexed. Then you have the user profile, Exchange. Exchange still just crawling the public folders, but since Exchange is also using the same search core as SharePoint is doing searches against Exchange is really recommended than to do the federation. Because if you do federation on the search side, you can get both access to your public folders and your private mailboxes. Then Lotus Notes and Documentum. Documentum, also a connector that has received a lot of updates related to security and functionality. If you want to extend this, then we have the BCS module. The BCS module is something that I will talk more about on Thursday in a developer session there at 10 o'clock on Thursday. So if you are interested in BCS, I'll recommend you to come to that session. I'll reference that session and promote that several times during this talk, I think. Then the crawl information is stored in the crawl database. This is just the metadata about the crawl, so all the statistics information, not the document itself. The document itself is stored just on a local disk cache and cleared when it's indexed. So just the statistic information. All the administration stuff, the configuration about your sources, crawl rules, stuff like that, is stored in the admin database. We used to have configuration like all over the place before. So in flat files, XML database, in scripts, in code. So this is a great new thing that we have all the configuration within the admin database. You'll see the admin database referenced on a lot of slides, but I won't insult your intelligence by mentioning it every time. So then moving over to the content processing. Content processing is the module where we crack open the different documents we feed from the crawler and index it. From the crawler, we receive the crawl properties and do processing, linguistic processing, lookups, enrich the content, and then maps it to manage properties and index it. Within this content processing, there has been some criticism that it's really locked down. You can't do all the customization as you used to do in the old ESP fast product set list. I'm not really agreeing to that. There are a lot of possibilities if you know how to use them. Content enrichment web service up here is one of them. And again, this is a component that I will talk about on Thursday. I'll create a web service and show you how you can use it, just as a simple example. Then, in addition, though, there are other possibilities to create custom code. So the flow, the conceptual flow at the bottom of this screen has some yellow boxes. Those yellow boxes are entry points where you can add some custom code. So you have the I filters. Out of the box, you have a lot of I filters, crack open Word, PDFs, Excel, all those different formats. If you're not happy with those I filters, if you want to extend it, maybe you have some specific document formats within your company, you can create your own or you can buy it from a partner. It could also be an I filter for specific Word documents, actually. So if you want to extract more metadata out of your specific Word format, this is where you can do that. So compared to the old ESP product where you could do all the customization to the different documents, this is a place where you actually can do this. Then we have this queues, which is the custom and extensibility web service. So the call out to this web service where you can create your custom code doing almost anything. There's a few exceptions. You can't work on the security attributes, so the ACLs, so you can't change those. But besides that, you can pretty much do anything there. Call out to other sources to enrich the content. Word breaking, also a place where you have an API to create your own word breakers or tokenizers, as we used to call it. Not that relevant maybe for most European languages, but for Asian languages, Hebrew, stuff like that, integrating third-party tokenizers like Malingo, it's a really key features for some companies and countries. Then we have the custom entity extraction stage, where you can add custom dictionaries to do entity extractions, so kind of create structured content out of your unstructured input. So you can extract elements from your Word files. Then we feed it to the index. The flow above, the update of security. So that one used to be integrated into this other huge flow. Now the index has what we call update groups. So instead of just one big flat denormalized table, as most search indexes are, we have divided the index into 3 update groups. One with most of the metadata and the documents itself, one update group with security information, and one with relevance information. So when you are doing a huge update to the security, so for example, adding a user or a group to a top-level site in SharePoint, this kind of propagates down, and you have to update maybe millions of documents based on that little change. That was really, really bad in previous releases. Now that you have this update group, as a database table, you're only updating the security attributes. So it's much, much lighter, and it's part of making the whole solution more cloud-friendly, because you have then much less I/O and processing on the index. Delete is obviously just delete from the index. Okay, let's switch to a demo. In this demo, I'll create a crawl property by adding just a custom element to a SharePoint list. Then I'll do a mapping to an already defined managed property. manage property or rollback. A crawl property, all the crawl properties is by default indexed. So you don't need to do any specific mapping or any magic to the crawl property to just get recall, to just get the search hits. But if you require some specific functionality, like a refiner, sorting, or that it should take part of the relevance model, then you need to do this mapping to a managed property to make it specific and so you can use it in your configuration. Okay, let's push the button. Okay, so this is get confused by the screen share. This is just a plain search center. So I created a search vertical called conference with some PowerPoints from different conferences. I have this stored in a SharePoint list. And within that list, I have created this custom property conference. And that is just done with in library settings, adding my column. Then after adding the column, then you have done, and by the way, I also added some values. This is just to save some time, so you don't have to see all this typing. So adding some corresponding values related to the different conferences where those PowerPoints are used. Then after doing this, I can do an incremental crawl. So then to pick up the changes and then automatically create this crawl property. So within my search service application, I can find my source, and I can start an incremental crawl. After my incremental crawl, I have created this managed property, and I'm ready to do the mapping to from the crawl property to the managed property. So let's search up. Okay, crawl property. And there I have my crawl property, and there's a lot of managed properties within the system, so search is also key in this case. I'll use a predefined managed property, so a refinable string. I could, of course, create this managed property myself. We have this dynamic schema in the search engine now, so at any time you can add crawl properties, you can add managed properties without doing any full recrawl of all the content. So, but I'm just using this one and click OK. Then, after doing this mapping, you also need to make sure that your values within this crawl property is actually also within this managed property. There's one or at least two ways to do this. You can do a full crawl over everything, which is really a terrible solution if you have millions of documents. But you can also go into your SharePoint list, hit advanced setting, and then click reindex this document library only. Because then you are touching this document library, so instead of reindexing everything, because the content itself hasn't been touched, so if you just kick off this incremental crawl, nothing will actually happen. You won't get that mapping in. But if you click this reindex document library, then you make sure that this is picked up at the next incremental crawl. So after you can click that one, and then back to your search sources and select the incremental crawl again. The crawler has a startup time of 2 minutes, and to keep this interesting, I'm not doing the actual crawl, so that's why I'm clicking outside here. So a little cheating. So now let's add my conference refiner to this search center. Edit the page and find my refiner. Edit web part. and click Choose Refiner. By the way, this is also something which is greatly improved with this version compared to the last one. So let's see if I can find my refinable string. And I can see I already get previews of the values within my managed property. Move it up to the top. Then I'll use something that we call display template. A display template, I'll reference that later too. That's just some piece of code based on HTML5 and JavaScript, which you are using in the new UI in 2013 to show you, to create your search center. Also, just a pointer to my presentation on Thursday. I'll use a custom refiner, so not one of the default ones, a pie chart refiner. And click Apply. And now, since it's all based on JavaScript, it's already appearing within this edit page. Click OK and save. And I have my custom refinable string in here. So I can look at my TechEd presentation, click on this pie, and this is the presentations for TechEd. Okay, that concludes that demo. So really easy to add metadata, add crawl properties, do mappings, create your own managed property, or reuse existing managed property to create custom functionality within your search center. Then you can use it in refiners, sorting, or rank tuning. Okay. Okay, now let's look at the index score. So the index score is probably one of the modules that received the most changes. One of the goals for this release was to make it not only cloud-friendly, but 100% supported in the cloud. Office 365 is the largest customer, to my knowledge at least, using the pieces. So it's all now 64-bit enabled, so meaning that the old problems we had with referencing memory, it's gone. It's about 20% of the IOPS that we used to have, so really improved on that side. It also has a lower footprint related to disk. We removed some of the old stuff that we had, the FixML, and it's also a new index structure which is more optimized. And in addition to that, it's also more fault tolerant. Let's have a look at that. So the index is stored within index partitions. Within each partition, which is a partition is like a physical unit of the index, and within index partition we have replicas. Replicas is just then a copy of that index. So to get fault tolerance or higher QPS, we have multiple replicas within that partition. So in this case, 3 replicas, all doing both indexing and search. So in case I lose something, I always have something which can immediately take over both the indexing and search. To extend or scale for document volume, so if I want to add more documents to my system, it's really easy by a new hashing that we have now in the index core to move over and divide the existing document, move over those documents that we need, and then add several partitions. So you can keep going. You can't keep going until the sky hits you, but because the current supported number is only 10. But I wouldn't worry too much about that scaling limitation. I know I'm working close with R&D, and I know some people in the audience here has special interest in that at least. So we are working with much better numbers related to scaling, and it's scheduled to be released really soon. So what happens if I'm losing this replica? Well, this was the dark green, so a primary replica. So the replica that was responsible for receiving the content from content processing. Those documents that were in processing at that replica when it crashed will bounce and will not be indexed. But due to the callback, the missing callbacks, we'll resend those documents. And then within 5 to 15 seconds, a secondary replica will take over as a primary replica. Then the documents are resent to this primary replica, and you're up and running and business as usual. With the expectation that with the only difference that you now only have 2 replicas. So if you're depending on the high QPS or the high query load, so you really need 3 replicas, it's important to get the crashed one up and running as soon as possible. Then it's synced automatically with the transaction logs, and it will then take a role as a secondary replica. The one that has the primary replica role will just keep being the primary replica. Okay, query chain. So what's old in this picture is the server-side object model, as we are used to using on SharePoint 2010 and previous releases. It's still in the picture, but it's not the recommended way of accessing your index. Now we have the client-side object model and the REST API. This is also with the cloud in mind, because you don't want server-side code to take down the whole cloud solution. So if I write any bad code on the server, it shouldn't affect you guys. It's enough and it's bad enough that my client or my applications are crashing. Within the web front end, we also have the search center with the different web parts and the display template and result types, something that I'll talk about on Thursday too, and then show you more about how you can use these templates to create the pie chart, how you can use it to add your own managed properties into the templates, so your own metadata. How you can use the client-side object model from as the search side to also then enrich the data further. Then further into the query stack, independent of what kind of access you're using, client-side, server-side, or REST API, then you hit the query processing. Query processing is has the same functionality, or not same functionality, built on the same technology as the content processing. So it's also a flow-based engine. So it has a lot of stages working on the query as we are working on the content when we index it. So we're doing linguistic analytics, we are doing lookups on dictionaries, and we're applying a new feature called query rules. Query rules is where you can create your own context-based boosting. You can make it aware of who the different users are that do the query, where they are located, stuff like that, to create custom ranking based on just looking at the different surrounding information. So not only looking at the query, but also looking at the information connected to who is doing the query. You can also create the query rules related to the query itself, of course. So there are some simple query rules with the product. So looking at, for example, if you do a search for SharePoint deck, instead of doing a plain query for deck, it kind of translates that to a PowerPoint, and then provides you PowerPoints, SharePoint PowerPoints. Within query processing, we also have the federation layer. So it's now a really improved federation against other result sources that you can define on your own local SharePoint index. So result sources is replacing what we call search scopes. And then to create more search-driven application, we can create result sources to filter down and only look at certain elements of the index. Then you can also do federation, of course, to other external SharePoint solution. Could be that you do a hybrid solution between on-prem and cloud solution, or if you're a large company, that you have several SharePoint installations around the world. You can also do a federation, as I talked about, to Exchange and to any search provider supporting OpenSearch. So it's really improved, and it can bring forward the security attributes really easy with a really easy configuration there. Okay, so let's have a small demo related to the query federation. See, I'll just need to. So we have this tool which is created by a colleague in Oslo using the REST API. So this tool can be used if you just want to have a peek into the index, if you're developing your own custom applications, or if you're playing around with the display templates, if you want to look at what kind of managed property is search retrieving for me, what are the values. So it's maybe a bit small. The only thing I want to configure is the path to my search. This could be a local or whatever kind of search. You can also use other authentication, so you can test it against the cloud solutions if you want to. And then I'll just provide a query and hit run. So then we have different tabs up here. So with some statistics information, so the query time for that query. We have the primary results. So this is where I can look at all my managed properties related to the index I'm querying. I can also, the tool also has some simple examples if you want to add refiners to your query. Run the query again with refiners, and I can then click on what kind of refiners I get back. I can use the tool just to click on the examples, or I can provide my own values. But this is really great if you just want to get the syntax. In addition, we have this secondary result, which is a result from a query rule. So I'm doing a federation here against Bing with a query rule, setting up a result source that using OpenSearch and bringing this in based on my query. So you can see here that I'm getting result from outside my index. So when you have this, you can copy copy this URL, and you can go into a browser and paste in the query, and you can then get the raw XML. This is what the REST API is returning. The stuff we saw in the tool is just a form, is how that tool is formatting that. So when you're building a more custom-driven search application, this is what you get. And you can see if I collapse here, I get all the different elements, like the query results here, and the refined results, and the secondary results. If I have a look at this within my search center, this is what it looks like. So doing a query for SharePoint, I get my federated results from Bing based on my query rule, and then I get the rest of my results. So this result block can, as in this case, be just pinned to the top. It could be ranked automatically, so starting up on top. But if I click on the elements below, it will over time fall down in my results set. And I can then hit show more if I want to go into more results from Bing related to my query. Okay, so short demo on that query tool. It's on Coldplex, so if you have access to Coldplex, it's just to download and try it out. No complex installation, just download and configure it with your URL to the search installation. Okay. If there are any questions, just raise your hand and I'll try to take them. Okay, analytic service. This is the final component of the architecture. Analytic service used to be an external component within the search architecture. Not used by that many because it was kind of a hassle to configure it and integrate it. Now it's all part of the integrated architecture. It's built on a MapReduce framework, so it's kind of like our little big data solution within the search engine. So taking signals from both content processing, so the link information and the anchor text, also all the event streams from your searches, both searches from the web frontend, so using the default SharePoint API, but you also have a REST API to use to feed into analytics service. Then processing all this information in addition to regular usage of SharePoint. So even if you're not doing searches, if you're clicking on documents within regular SharePoint lists, you also feed this information into this analytic processing engine. And then the larger the system, the more data, of course it gets a lot of signals in there, and that's where we are using this MapReduce framework that easily can scale out to cope with huge amounts of data. It learns by usage, so this is kind of like the user-based tuning. So whenever we are processing this analytic information, we feed the information back to the index, which is kind of unique, I think, compared to a lot of other analytics services. We actually feed the information into the index, so then updating this update group related to relevance. So making it possible to then do additional queries or do queries on that information only. So related to recommendations, there's just some separate, not query language, but some properties that you can use to get recommendations, so item-to-item recommendations. In addition to feeding into the index, also creating some reports. Not super granular, but some reports related to usage information and what we have in the system. So analytics service empowers the view counts. So you have this icon on your SharePoint list, most popular, and that's provided by the analytics service. So you get all the views, all the clicks related to the different items. You also get this view count when you're doing searches. So up in the upper right corner, you have this number of views. And we have this recommendation. So recommendation really a lot used in regular e-commerce settings. So whoever has bought this TV also bought this product type thing. But you can also use that in productivity settings related to searches on documents. So because the information is collected and fed into the index, so you can use it in like a hover card, for example, to do secondary queries, as I will do on Thursday, to then get recommended items or recommended documents related to this document that I found. So kind of providing the wisdom of the crowd. So even if you didn't think about searching for that specific document, other people's did. So then you can provide a lot richer search experience than just doing the plain keyword search. In addition, as I said, we have the search reports, and we also have this suggested sites, suggested documents. All that stuff is then empowered by the analytics service. Okay, let's move over to deployment and scaling. So related to sizing, there's kind of two ways to do the sizing. You can scale up or you can scale out. Scaling up is adding more CPU, more memory, more disk to your system, so kind of creating beefier hosts. By scaling out, it's just duplicating whatever hosts you are using. The search engine usually just use the scale out solution. And especially now when R&D is doing all the testing based on virtual images or virtual machines, then we kind of have one definition of a virtual image that we are scaling out in. Related to but then using more beefy hosts, you can of course run multiple VMs within that host. Related to that, you need to think about what kind of resources you are sharing within the physical hosts. Because if you remember my partition with all the replicas, if all the replicas run within the same physical server and that physical server crashes, then you're losing the whole partition and search is down. Then you need to switch to a disaster system if you have disaster recovery system if you have that. So think about that, sharing what kind of resources you are running within the same physical host. Related to physical and related to Windows 2012 and 2008, if you run directly on a physical host, which you of course can, and it's supported, there's no difference between running within 2012 or 2008. But if you go virtualized, 2008 has a limit on how many CPUs you can assign to a virtual image. It's 4. And by that, you also then need to split out an installation into 2 VMs. At least that's recommended. On my test server, I'm running everything on one anyway, though. But it's running, but if you're going in a production environment, it's really recommended to split it out. If you're running on 2008 or VMware, for some reason I didn't use that as an example here, then you can, of course, run it in a console, everything on one, because you can assign much more CPU to that. As we'll see later, I'll show you some demo on related to resource usage, and you can see that we are really using a lot of CPU in the system. So the scaling after the CPUs are kind of important. Starting out my scaling examples with the small topology, so everything below 10 million. Maybe kind of wrong to call it small because I think 80 to 90% of the customers are within this segment. But anyway, it's defined as small. To get a fault-tolerant system, I'm just duplicating the installation. So as we saw on the 2008 scaling example, running the admin, the content processing, crawler, and analytic processing on one VM, and then the indexer and query processing on a secondary VM. Then on a different physical host, I'm running the exact same setup. So in case my indexer fails or the admin node fails, then I always have a fully fault-tolerant system. This is also new in this release because we previously, some of the components, for example, the admin components, was not fault-tolerant. So it was not possible to build a fully fault-tolerant system. If you are running with 2012, you can then run everything on 2 VMs within 2 physical servers. So the difference here is probably mostly a license cost, because you will need obviously 4 licenses for the 2008 setup, while 2 for the other ones. But in my presentation, I'll use the expensive model going forward. Okay, a medium installation is defined to be from 10 to 40. So since each index partition supports 10 million documents, we need 4 of those. And so to support that, we will add 2 physical servers, and then start by moving out the index and query component. This, since also the analytic processing components is also kind of resource heavy, so we want to separate those. Then I'll add 4 more index nodes to support the 40 million number. Then I'll move over the analytic processing component, and I'll add a content processing component to that VM. So now I have scaled out, so I have more capacity on the input side, processing documents to this content processing component. You only add 1 to the server, and then within that content processing, it's automatically scaling up to 4 threads if required, if you have a lot of traffic. If you don't have a lot of traffic, it's just using 1 thread processing in that. Then if I want a fault-tolerant model of this, I just duplicate everything. Then, just flashing this, the large topology, 100 million. It's no point really talking about the details in this setup, because if you go this large, I think it's important to kind of think about what are you scaling for. Are you scaling for high QPS, so high query load? Is it like an internet site? Is it a website? What kind of sites are you supporting? So are you scaling for high or low QPS? Are you scaling for purely this document volume? Or are you scaling for high throughput, so low index latency? So those three dimensions is really important when you go this large, and I think you need to think carefully about how you set up, because if you're scaling for a high document volume only, the system is just an archive system. You don't need all these nodes. If you're scaling for high QPS, well, then maybe you need more nodes. If you're scaling for low index latency, well, then maybe you need more nodes doing the content processing. So just a plain example, but I think it's important to think about what are you really scaling for. Just showing up this scaling cheat sheet to show what kind of components are using what kind of resources. So the index is surprisingly not enough using most of the resources here. It's high on CPU, fairly high on network, high on disk, and high on memory. So all the details here, you can download the presentation afterwards and use it, I think. Then also showing up this one related to disk sizes. So just one note related to this diagram is that the index component and analytic component is scale related to per VM. So 500 gigabyte per VM on the index component, while the database component is scaled as a system, as a total system, so the full size of the system. The numbers are based on testing in R&D, but I know customers that has seen a lot less disk usage. What's important to remember, though, is that you can't really look at the disk after indexing and crawling when it's idle. You really need to look at the disk you are using while processing, because there are some workspace, some work files, so the index is compressed and optimized for high IOs when you're doing the queries. But while you're doing the crawling and indexing, you're working on the uncompressed format, so you need more disk space than you need on the idle index. What can you do in the cloud? Well, you can do a lot in the cloud. So Office 365, a lot of sessions on that at this conference. I think it's a really great place where you can get started with search. You can get your content that you have in Office 365 indexed there, and you have a search center. You can do query rules, you can create applications. If you need access to the content source, adding content sources, it might not be the correct place. So then you can move over to Windows Azure if you want to be in the cloud there. So using Windows Azure for internet sites or for development and testing. Okay, let's have a quick demo or a demo now on the components in action. So this is a setup where I have 8 different physical hosts, each running just one VM. So this to make sure that my resource used on the SQL server is not also showing up on my admin node. So each of these components runs on different physical servers. I'll start with a crawl load scenario. So based on a SharePoint crawl, so crawling the web front end itself provided by SharePoint, so crawling, so it's accessing itself. The crawler has been paused, so I'm just resuming it. This to prevent this 2-minute startup time that we talked about. And I'll do it without hands, it's recording. So it's resuming the crawl, and then we'll see what kind of resources we are using. So as the crawler picks up, it will access the web front end. We'll see some CPU traffic there, and then the web front end will access the SQL server to grab the content. After a while the crawler has processed some content, we'll slowly see the content processing component picking up also on CPU traffic, CPU resource. The content processing doesn't store anything to disk, doesn't use any network, so we'll only see the CPU there. As the content processing pushes content to the indexer, we'll slowly see the indexer also has some CPU activity. We'll not see that much disk activity on the indexer, only some bursts, because the index is now working in memory on the first level. So indexing in memory, both to save the I/O, so also to have a better freshness. But then we'll see some bursts of indexed activity or disk activity on the indexer when it's then storing to disk. We'll see a lot of network traffic between the crawler, the web frontend, and the SQL server. So this is because of all the content is going between those nodes. Okay, then let's look at the query load scenario. So to simulate the query load using Visual Studio, starting with 5 users, and then every 15 seconds increase by additional 5 users. Those 5 users represents the query traffic, so adding query traffic to the system to see what kind of resources we're using related to the query load. So starting up Visual Studio in a while. Then you can see we are starting with 5 users, and then every 15 seconds increasing by 5. Then let's kick off the test. And now we'll see that we're using a lot of CPU. So related to scaling for CPU, then you can see this on this demo that we're actually using a lot of CPU, both on the web front end and the query processing. So then crunching the queries, applying the query rules, and doing the dictionary lookups and linguistics, and then hitting the index. On the index now, you can see much more disk activity. This is because now all the index is stored in files. It's not stored in database, so it's barely no disk activity on the database. As you can see, the QL, missing S there on the SQL server. So the index is only stored on disk, but you see some burst on the SQL. You just saw one on the SQL server there, and that's just the query logging. So only logging related to the search process on the SQL server. So if you're losing your database, you can still do searches. You just don't get the logging. And then you can see that when we're increasing and reaching our 25 users, I think, then we're kind of maxed out what this system can handle related to query traffic. So this video is then part of the presentation, so if you download that, you can play it and impress your coworkers. Backup and restore. I talked to some partners today, and they claim that nothing has happened to backup and restore in 2013. I think that's not entirely true. I think it's greatly improved, and it's now based on a point-in-time backup. So you don't require any downtime on your query side. You're pausing the crawling just for the point that you take the snapshot, and then you continue as usual. It's kind of proven that it's more stable and robust now, since Office 365 is using this every night and is using it to keep the disaster recovery up to date. So in addition to just being used for disaster recovery, you can also use it if you want to move between environments. So you can use it if you want to move between QA and production. So taking a backup of your QA, you can restore it to production, and production in that case doesn't need to be the same exact layout of the modules. So you can use it to kind of scale up and scale down. And then, of course, you can go the other way from production to QA, scaling down if that's necessary. So that's a really good way of getting a duplicate of your production system over to a test environment if you have some problems that you want to debug on the side. You don't want to do the debugging in production. Then we have the disaster recovery. Hot, warm, cold, just like coffee. Hot, meaning that we are doing the backup and then doing a restore to the disaster recovery environment, and then restarting the crawler based on the point in time where we did the backup. That way, the hot disaster recovery system will pick up and then be completely in sync with your production environment. So if you are required to switch over to disaster recovery, the user will probably not notice at all that that they changed environments. The warm disaster recovery is kind of the same thing. You're doing the backup, you're doing the restore to the disaster recovery system, but you're not restarting the crawlers. So in case you need to switch, then you do the restart of the crawlers, and then the user will probably notice that there are some changes in the search result for a few minutes before the crawler has picked up and taken all the new documents. If you're doing the cold way, then you're only doing the backup. You're not doing a restore to the disaster recovery system before we actually need it. And then you don't need the VMs in hot standby, and you don't need the licenses for it. So it's a much cheaper solution. Migration. So there are 4 different migration paths, or actually there are multiple migration paths depending on where you're starting from. But if you're starting from SharePoint 2010 or FastServe for SharePoint 2010, these are at least 4 paths. So you can either do a re-implementation, you can do a search first migration, or you can do a migration from SharePoint 2010, or a migration from your FastSearch for SharePoint 2010 solution. So the re-implementation. That means that you re-implement both search and the content databases. You scratch everything you have, and you reinstall, and you get your new system up and running, starting from scratch with everything. The search first migration, my personal favorite, and the customers I have talked to also prefer this way of doing migration, because it's something that you can do more over time. So you can get up your SharePoint 2013 installation with search only. You configure the sources, pointing the sources to 2010 and all the other sources that you have within your 2010 solution. You're doing the crawling, and you can then consume from 2010. You can consume the index in SharePoint 2013. That way, you can then use all the features. If you require to run in a cloud environment, virtual environment, you can use those features, and you also get access to all the other great functionality related to query rules and the federation that you have in 2013. You can, of course, then do a migration. So a migration from SharePoint 2010 to SharePoint 2013. It's not that complex. It's a well-documented approach, so could be a good solution. You can then run in a SharePoint 2010 mode, so what we called 14.5 for a while in Microsoft. And then later on, you can upgrade the user experience by upgrading the Search Center to your 2013 mode. You can do the same thing if you have a fast Surf for SharePoint installation. It's not that straightforward as if you have the search server installation as a starting point. There are some custom or some PowerShell scripts provided related to this, but those are not complete. It's well documented what kind of thing you not get migrated, so you need to do some custom work related to that migration process. Then the same thing, you can then start with the 2010 mode and then later on, when it's stable, upgrade to a fully 2013 solution. You can, of course, then also do the search first migration related to fast Surf for SharePoint. So the question is really when to do what, I think. And this is kind of what's good for you and your project. So, but just some initial thoughts from Mai on this. So when doing a re-implementation, so that could be if you have invested a lot in PowerShell scripts and scripted installation for 2010. So it's you really want this IP brought forward. So you want to invest some time in doing just changing those and then run that on a new installation. Or you could have like a really simple out-of-the-box solution. So there are no customizations there. So there is nothing to really bring forward, but it's just easier to re-implement since you didn't do anything specific at all. It could also be based on your business requirements. You have a lot of old business requirements, but you have a lot of new business requirements too, and maybe you don't want to bring forward all the old business requirements. You want something new in there. You want the new business requirements and get rid of some of the old stuff that people is not using any longer. Then re-implementation might be what you're looking for. Then the search first migration, the reason why it's my favorite is because it's the easy one, and you just get access to all the different features. So support for the cloud environment, all the features related to scaling, fault tolerance, and query rules and all that stuff, without actually doing the migration of your content sources. That way you can do more like a gradual migration. So starting out with search and then later on move the content sources, then just changing or updating your content sources, the crawl sources, to start crawling the new content as it's moved over to 2013. It could also be that you have a lot of custom functionality, custom code developed on your old SharePoint solutions, and it's kind of hard to migrate or re-implement that, but users are still using it. You just want the content indexed. Migration, also something that you can do if it's really an out-of-the-box solution, but it's usually kind of troublesome, so it can be difficult and complex. But if you have done a lot of investment into, for example, your search schema, you want that stuff brought forward, then migration could be your solution. So just some thoughts, no real guidance related to when to do what. Okay, short recap. We have talked about the search architecture. Hopefully you learned something about some of the new features we have in there, some of the great functionality related to support in the cloud, how to run on a virtual environment, some of the custom, some of the possibilities for custom processing, the REST API, the query rules, and the analytic processing component. Then related to scaling, some examples related to small, medium, and large. But what's really important is to think, what are you scaling for? So even if you're small, you might scale for a high QPS if you have a shopping site. So then you for sure can't use my example there, but you need to add more indexer nodes, query capacity to the system. Then just some initial thoughts related to migration, some paths, some examples, what you can do, when to do what. Okay, that kind of concludes my presentation today. Any questions?